Hello everyone, today I am going to explain about module 1 microcontrollers bcs402. That subject and the subject the module 1 is important topics we are discussing about today. Now, so first of all, first question is difference between the microcontrollers and microprocessors. See here, the microprocessor and microcontrollers are the microprocessor is a heart of a computer system, but in microcontroller is a heart of a embedded system. Then come to processor. The processor is a memory and input output have been connected externally, but in controllers the external process along with the internal memory and input output components. And then come to third point. Since memory input output connected externally, the circuit becomes large. Since memory input output present internally, the circuit becomes small. So then fourth point is connected to be used to compact system and hence insufficient, and can be used to compact system hence it is an efficient technique. Then fifth point is cost of the entire system is increases in microprocessors. The cost of the system is low in microcontrollers. Then that one also important point. Then the external due to the external component, the entire power consumption is high, so it's not suitable to use with devices running on the stored power like batteries. And then in controllers the system external components are low, total power consumption is less, can be used to device running on the stored power like batteries. And then next another point is the most of the microprocessor is do not have any power saving features, but in microcontrollers having a power saving mode, that idling mode, that power saving mode that helps to reduce the power consumption even further. Then since even memory and input output components are all external, each instruction will need to external operation, hence it's relatively slower. But in controllers that components internal, the most of the operations are internal, so intersection, hence it's fast. Then go to the last point will be the microprocessor having a less number of registers, hence more operations are memory based. Microcontrollers having a more number of registers, hence programs are easier to write. That the advantage of the microprocessor and microcontroller. Then go through the risk design philosophy. That risk design philosophy we consider as risk diagram. And then first we have to discuss what is the risk design philosophy is. Means aim to simple but powerful instruction that risk is a simple but it is a powerful instruction that executes a single cycle with a high clock speed. That is the first point. It's one of the important, I think, that one. See here the aim mode, but it's a simple but most powerful that execute in a single cycle with a high clock speed. And then come to the next point, concentrate on the reducing the complexity of instruction performed by the hardware. Means that reducing the complexity due to during where that performance by the hardware time, that concentration will be reducing. Then provide a greater flexibility and intelligence software rather than the hardware. Means that provides in greater that flexibility and intelligence you should return here whenever that risk type will ask. So that one is also important. Then go through that implemented four major design rules in risk philosophy implemented. That what are that means the instruction pipeline registers and load and store instructions. So load and store architecture. So first we have to discuss one by one that what is instruction. First we have to discuss, then go through the pipeline, register and load and store. The instructions are used in risk that reducing the number of instructions classes. That classes is provide a simple operation that which execute a single cycle. Each instruction is a fixed length. Allow the pipeline is a future instruction, but before decoding the current instruction that tells about that instruction risk. So what is the risk means? I think you are understand. It means what the reducing a number of instruction classes. This classes is providing a simple operation so that each is executed as a single cycle. Then each instruction are a fixed length allowed to pipeline fetch future instruction then before decoding a current instruction. So that one. Then pipeline is a process of instruction is broken down into smaller units. That means that instructions are broken down into smaller units. That's called as a pipeline in a simply way. So you see that broken down into smaller units that it can be executed parallel by pipelines. That's uh, pipeline means that instructions are broken down, right? That part you have called as a pipeline. Then go through the register. That registers mean that risk mission is having a large general purpose register. Set any registers can contain another data or an address. Then load and store architecture. That processor entire register separate load and store data transfer that can be used in load and store architecture that transfer the data between the register bank and external memory. These design tools are a RISC processor to be simpler, but the score can be operated in a higher clock speed. And then see here that CISC and RISC diagram and difference is there. Here see that greater complexity is fetch on processor in CISC, but greater complexity fetch on compiler and the RISC. See that difference between the RISC and CISC, that is a very important question. In most probably they will ask in this question in 2022 scheme paper. See here. So difference between the RISC and CISC means first we have to write the diagram. Small diagram will be that compiler to code generation that will show RISC and CISC diagram that emphasizes compiler complexity here, but in CISC that emphasizes processor complexity, and then some but powerful instruction in RISC, but here no more complicated in CISC. That is the difference between the RISC and CISC. And then some another is also there. See, in execution is single cycle, but in CISC will take as many cycle to execute. But instructions are a fixed length in RISC, but the instructions are variable length. Then having a large general purpose register, but a limited general purpose register in CISC. Any register can contain either data or an address, but in RISC, so dedicated registers in specific purpose in CISC. Then separate load and store instruction transfer the data between the register and external memory. But in CISC, move instruction can be used to transfer the data between the registers and memory. That is a RISC and CISC difference. See here once again, the diagram emphasizes a greater complexity where it compiler, then it is a processor is a greater complexity. Then go through the simpler but powerful instruction. Here they are more complicated. Then RISC is take a single cycle, but it take a many cycle. Then instruction is a fixed length, but is variable in the never large and general purpose registers. Then having a limited set of a general purpose register. Then go through the next point is registers and content, and then either data and address. And the RISC here that I take a separate load and store instruction transfer data between the memory and registers. But in CISC take in a move instruction can be used to data on either memory registers or memory transferred to the use of a move. Then go through the ARM design philosophy. That ARM design philosophy, see here that one is also how we'll ask means explain briefly about the ARM design philosophy or write the physical features of a ARM processor. The both questions are same, we have to write the same answer here. So see here, following the ARM design philosophy is given. The ARM processor has been specially designed to be small, reduce power consumption and extended battery operation, and essential applications such as mobile phones and personal digital assistants. Means what ARM design philosophy where we are using means that such an application, essentially that application we are using in mobile phones and personal digital assistants, we are using a ARM design philosophy. Then smaller reducing power consumption, that means it's not taking much power to generate means running the machine that device. You have to using a small power, you can run that device and extend battery operation. Means essentially application are used where you are using means phones and personal digital assistants. Then go through the next point will be high code density. Then major requirements of this embedded system having a limited memory due to the cost and physical size restrictions will be there. So that a high code density useful to application that can have a limited on board memory. So that mobile phones such as a mobile phone, see in mobile phones so many softwares will be there that where you are using a ARM design philosophy, because it is low power consumption means small reducing a power consumption and extended battery operation will be there. So that's why you have to using a mobile phones and such an limited board memory will be there. So then go through the next point is embedded system as a price sensitive and use a low cost memory device. Means it's available in a cheap and best, means low price will be will get it, that ARM design philosophy. Then embedded system are price sensitive, that means low cost memory device, same mean. Then go to the next point is another requirements is in reducing area of a taken in embedded processor, means it is a device is very small, single chip solution for a smaller area used to embedded system processor available space specialized peripherals. Then means don't want any much space to place. It's want just some little bit space, we can fix it that ARM design. Then means ARMs. So then go through the ARM has an incorporated hardware debug technology with the processor. We can software engineer can view the happening while processing executing code. Means we can see the software engineer can view that ARM design. That is the what ARM design philosophy there. Then go to the instruction set for embedded system. That thing, what is there in instruction set for embedded system means, see here that specially considered as in some 5 types. The following ARM instruction set for set of embedded system is not much important, but see here once. Sometimes they will ask, so instructions for embedded system. So most of the times they will ask embedded system hardware and software. So this question will neglect it, you don't want. So if you want, you can read that. See, take a screenshot. So that's why I didn't explain that question. So to go through the next question is embedded system hardware. See that embedded system hardware is specially considered as one diagram. That diagram is shown here. So see here, you should write that time whenever they ask the embedded system hardware in the exam paper. So you should write how they will ask, means there are two types, the different types of questions will ask. Means the night read diagram explain the harm design embedded device called microcontroller, or need diagram explain different hardware components of embedded device based on the ARM code. So anytime you will ask, but you write only one same answer. See that diagram. Then you can consider as a ARM processor. ARM processor will connect it to the interrupt controller and HP arbiter. Then here right side we have considered as in memory controller and HP external bit. The HP external bits are considered as connected to the ROM, flash ROM, SRAM, DRAM in external bus, and HP and APB bridge will be there. Then real time and Ethernet is serial UART and counter timers. So you consider cancel. You should write. Then we hear that mainly you should write four main things here. What they are means that ARM processor, controller, peripherals, and bus technology. Means bus you have to write. So ARM processor means the processor controls the embedded system. The different various of processors are available. That means that different versions of ARM processor will available. So these are operating characteristics that can be used used to control the embedded system. Then controllers means that words also tells what is controllers. Controllers and codes important block of a system. That commonly is memory controllers and interrupt controller. Then peripherals provide all output and input capability of external to the chip and responsible for uniqueness of an embedded device. And then bus, what is a bus means it is used to communication. That way you have to using a bus between the different parts of the device. Whenever you communicate the one device to another, that middle mediator, that's called as a bus. That's why you have to specifically using the word of a bus. Then go through the ARM bus technology. That ARM bus technology, we come to the ARM bus technology. Here you have to hardware that must include ARM bus technology. ARM bus technology is nothing but that embedded device can use the chip, that internal chip that allows to different peripheral device in interconnected to the ARM core. That's the ARM bus. That two different types of classes in device attached to the bus. So first one is bus master and then another one is bus slaves. So first we have to consider the ARM processor core is a bus master. There is a logical device initiating a data transfer. That what's the function of a bus master means initiating a data transfer with another device across the same bus. Means within the same bus we can this can capable to data transfer to the logical device, initiating a data transfer within another device across the same bus. So that's the function. But bus slaves is a simple thing that helps with the bus master. That's the same. See here, peripherals tends to bus slaves, a logical device capable to responding the transfer request from the bus master's device. This is responding. That's the use of peripherals. And then AMBA bus protocol. That AMBA bus protocol means that advanced microcontroller bus architecture that we have introduced as a 1996 and has been widely adopted as on the chip on architecture used as a ARM processor. Then the first AMBA bus protocol is used as a ARM system bus, and then ARM peripheral bus. Later you have to using a ARM introduce another bus design. It's called as ARM high performance bus, means AHB. We call it as an AHB. Then AHB provides a higher data to output ASB. That's why you have to using a instead of ARM and ARM bus and ARM peripherals, instead of using a ARM high performance bus, because it's providing a high data through output the ASB because of centralized multiplex bus schema rather than the ASB bidirectional bus designs. That is the meaning of a AMBA bus protocol. Then another one is a memory. Then come to the memory. Memory is an important thing. So see that memory we can consider as a main memory and secondary memory in hardware. That embedded system has some memory stored to execute a code. Figure below shows the memory trade of the fastest memory cache physically located nearer to the where it located means it is nearer to the ARM processor core, and slowest memory slower secondary memory is set further away. General closer memory to the process core that more cost is smaller its capacity. That is the memory type. Then go through the peripherals. What is the peripherals? See the diagram. That is a simple diagram you should write. That I will get in much marks. I think because it impressed that examiner. Then go to the peripherals. Peripherals is nothing but a embedded system is interact with the outside the world. It need more peripheral device. The control specializes peripheral implement a high level of functionality, and then within the embedded system. And then memory control, interrupt control we have to consider. The memory control controls the connect different types of memory to the processor bus. The interrupt controller the programming governing policy that allow to software determine much within peripheral devices can interrupt this processor at any specific time. That is the peripherals. So this is about hardware. Then see here first we have to consider as 4 main components. What they are: that ARM processor, controller, peripherals, and then bus. What ARM processor, controller, peripheral, bus, and then next we have to write the ARM bus technology. Then AMBA bus technology we should write. Then AMBA bus technology, advanced microcontroller bus architecture is widely used where 1996 that widely adopted in on-chip and bus. Then go through the memory and peripheral should write. Then go through the next one is then explain the AMBA bus protocol. That is also same thing here. So that's why I didn't explain here. So see here once I will read once that advanced microcontroller architecture that introduced 1996 widely used adopted on chip. Same thing you should write in before what you study that one you should copy it. You will get a marks that later ARM introduced another bus technology is called as a high performance bus AHB that using a AMBA peripheral design. The reuse the design for multiple projects because there are large number of peripherals developed with AMBA interface. Then peripherals can simply bolted onto the chip without having a redesign and interface design process architecture. The plug play and interface hardware developer improves the availability time and market. The AHB means higher data through output the ASB because of based on a centralized multiplexed bus schema rather than the ASB biodirectional bus design. Then EHBs run higher clock speed and fast arms support with width 64 and 128 bits. Then go through the ARM introduced two variants that AHB and bus, the multi-layer that AHB and AHB leads that contract the original AHB that allows to simple master activate the bus anytime. The multi-layer AHB that allows to multiple active bus master. AHB led the subset of the AHB was limited a single bus master. This was developed for design do not require full features of standard AHB bus. Then next to see that questions embedded system software before we learned what is the hardware embedded system model. Here we learned the embedded system software. See the diagram first. We have to write the diagram. You should write it that in diagram there is simply table that will there. So you see here the application operating system initialization device drivers hardware device. That's it. You have to write then go to the we can consider the show. That's it. Here see in software system you have to write the initialization means boot code. The initialization is take a processor from the reset state where the operating system can run. The first code executed on board on specific particular target or groups of a target. Handler number of administrative tasks pre handling cover an operating system means that initialization code or a boot code we can call. Take a processor from the reset the state and state where the operating system can run means operating system can come that the processor can restate to state where the operating system the first code is executed on board the specific and particular target group of a targets. Then handle number of administrative tasks pre-handling control of an operating system. You can group the different tasks into three phases. That three phases are initializing hardware configuration, diagnostics and booting. That was the important points you should write that in examination because you will get an marks here only. So see here initialization part that we have to mainly have to write the what installation hardware configuration, diagnostic and booting. So what is the function of installation hardware configuration means involves setting up a target platform so it can boot an image. Then what the function that can boot an image. Then diagnostic, what is the diagnostic means the primary purpose of a diagnostic code is fault identification and isolation. That is the meaning of a diagnostics. and then go through the booting is involves to loading an image and handling and control over the image, and loading an image involves copying an entire program including a code and data into the RAM. That is the booting section. Then go through the operating system. Then operating system organizing data resources, that is a peripherals, memory and processing time, that we can consider as an operating system. So see here once again that initialization means you have to consider initializing hardware configuration, diagnostic and booting, but it is using a resetting the state to state where the operating system can run. That first we have to write that first point. Then the first code is executed as a board that a specific particular target and the group of a targets, that one you have to write. Then go through the next point is handle the number of administrative tasks, clear handling control over the operating system, that one you have to write. Then go through the three category parts will be there, that phases we have called as a phases. That phases, what are the phases means initial hardware configuration, diagnostic and booting. Then operating system, then go through the operating system, what is so go for okay sorry. So see here again that initial hardware configuration, what that there is boot an image. Diagnostic means there is a diagnostic fault identification and isolation. Booting means is a booting an image, that handling a cover over the image, loading an image involves copying an entire program including a code and data into the RAM, that one you should write. Then operating system, see the what is the application of operating system or advantages of applications. Operating system is, then operating system organize system resources, peripherals, memory, processing, that is the main function of an operating system. You also know that you can write naturally, means you can write own also, you will get a marks what is the operating system. That means that ARM processor supports 50 operating systems, means what ARM processor supports over 50 operating system. Then we can divide a operating system into the two main categories, real-time operating system and then platform operating system. So real-time operating system provide a guaranteed response time to event, means that real-time operating system generally do not have any secondary storage, so that's what that given a guarantee. Then platform operating system is requires a memory management to manage large non-real-time application, tends to having a secondary large, that should have to write. Then go through the device drivers and application. So device drivers, what is the device drivers will be there means device drivers are third component that provide a consistent software interface so that the peripherals on the hardware device. Application is finally application perform to the task required for the device. For example, mobile phone might have a diary application. They have multiple applications running on the same device, control to the operating system by means that phone. You can take an example. You can tell is that phone the multiple applications is running simultaneously. That time you have to operating system. It works on tasks. It means perform better. Then application embedded system can have an active application and several applications running simultaneously. So software component can run a RAM, ROM and fixed device card as a firmware example installation code. Then remaining part we can discuss about the next section. Thank you.